Finding the linear nth term with adamonlinetutoring. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. Find the nth term of the following sequences. A sequence is an ordered list of numbers that follow a specific rule or pattern. An arithmetic or linear sequence is one where each term increases or decreases by the same amount each time. So for the first sequence, we can see to get from one term to the next, the term-to-term rule is adding 6. We call this the common difference since it's the same amount each time. The nth term is a formula that lets you find any term in the sequence by substituting n, which is the position of the term. Before using the nth term, it's important that we're able to find the nth term. Finding the common difference is the first step, since this helps us to identify the multiple of the position needed to get from the position n to the corresponding terms. So for the first sequence will be 6 lots of n, which would be the 6 times table, and the 6 times table is 6, 12, 18, 24. If you compare 6n to the corresponding terms in the sequence, you can see that they don't match up. To get from here to here, each time we would need to subtract 3, meaning that it's the 6 times table, or 6 lots of n, minus 3. We call this the constant. There is a quick way of finding the constant without having to write down the times table and looking at the difference between them. And you can do that by finding what's called the zero term, which would be the term before your first term. So to calculate this, we'll need to do the inverse. If the sequence is increasing by 6 each time, then the inverse would be subtracting 6, and 3 take away 6 gives me negative 3. Whatever the zero term is of a linear sequence will be the same as the constant at the end of your nth term. Applying the same logic to the next sequence, we can see that it is linear or arithmetic because we have a common difference and it's decreasing by 3 each time. This means that my multiple of n will be negative 3n, and rather than writing down the negative 3 times table to compare, I will apply the inverse to work out my zero term by adding 3 to the first term, giving me a zero term of negative 7, meaning the nth term is negative 3n minus 7. On to the intermediate question, with an increase in difficulty. Here is a sequence of patterns made from white tiles and grey tiles. Firstly, we need to draw the fourth pattern. As you can see from the first pattern, we start with 2 white squares on top of each other in the middle, which then goes to 3 for the next pattern, and then increasing to 4 on top of each other in the middle of the third pattern. So you can see that white column is increasing by 1 each time in the middle. This would be a good place to start for pattern number 4, which would be 5 white squares in the middle. On either side of the white column at the top, I have 1 grey square, which then increases by 1 going down each time. So by the time I got to the fourth pattern, I would have my grey squares starting at the top and will go down on each side, just leaving the single square by itself at the end. And I'll shade these in to show the difference between the white and the grey squares. Find the nth term for the total number of tiles. It's useful to change the number of tiles shown as a diagram into some numerical values. For the first pattern, we have a total of 4 tiles, 7 for pattern number 2, 10 for pattern number 3, and 13 for pattern number 4. Now I have the sequence written numerically, I can use my terms to find the term-to-term rule, which in this case does provide me with a common difference, meaning it's a linear sequence, and the nth term would be 3 lots of n with a zero term and a constant of 4 take away 3, which gives me 1. Therefore, the nth term for the total number of tiles would be 3n plus 1. On to the advanced question, one of the trickier questions that you're likely to find on this topic. Here are the first 5 terms of an arithmetic sequence. The nth term of a different arithmetic sequence is 4n plus 15, and then it gives some criteria. The last term of each sequence is the same number, and they have the same number of terms in each sequence. How many terms are in the sequences? We could write the sequences out and continue to find all of the terms until we find the same number in both of the sequences. The problem with this is it could be the 100th term, and it will take a long time to list the first 100 terms of each of these sequences. Instead, we can solve a problem like this using the formulas for the nth term. I'll need to start by finding the nth term of the given sequence at the beginning, finding the difference between the first few terms, so I know the nth term will involve 5 lots of n, and my 0 term would be -3, so the nth term is 5n minus 3. Because the problem states that the last terms of both of the sequences are equal, we can set these two expressions for the nth term equal to each other. So we want to find n when it's the same for both of these sequences. And at this point, solving the equation will give us the corresponding value for n, which will represent the number of terms in each sequence. Taking away 4n from both sides will give me n minus 3 is equal to 15, and adding 3 to both sides gives me n is 18. Therefore, the number of terms in each sequence is 18. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are and write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.